Today, continuation of successive differentiation or second derivative. So, then continuation. If y equal to tan inverse x, prove that one plus x squared into y2 plus 2x y1 equal to 0. So this. Given y equal to tan inverse x, differentiating with respect to x. Y differentiation y1, differentiation of tan inverse x, 1 by 1 plus x squared. On cross multiplying, one plus x squared into y1 equal to 1. Differentiating again with respect to x. Bracket first function, differentiate y1. y1 second function, differentiate first function. Product. Differentiation of y1 is y2. Differentiation of 1 plus x squared is 2x. One constant, differentiation 0. 1 plus x squared into y2 plus 2x y1 equal to 0. Okay, sorry. This is same as 1 plus x squared, y2 means second derivative, plus 2x, y1 means first derivative. If y equal to e to the power m cos inverse x, prove that one minus x squared into y2 minus xy1 minus m squared y equal to 0. So given y equal to e to the power m cos inverse x, differentiating with respect to x. Y differentiation is y1. Differentiation of exponential. Differentiation of exponential as x. First as it is. composite differentiate power. Power is m cos inverse x. M constant, differentiation of cos inverse x minus 1 by root of 1 minus x. First as it is, then differentiate power. Differentiated by sin. By this formula, first as it is, then differentiate power. Power m constant, differentiate cos inverse x. y1 equal to minus m e to the power m cos inverse x by root of 1 minus x square. On cross multiplying, root of 1 minus x square into y1 equal to minus m e to the power m cos inverse x. Root of 1 minus x squared into y1 equal to minus m gives 1 e to the power m cos inverse x. E to the power of m cos inverse x is 1. Squaring both hand sides because to remainder root whole square, root cancels. Square y1 square minus whole square plus m whole square m square y whole square y square minus whole square plus m whole square m square y whole square y square. Differentiating again with respect to x. Product. Bracket as it is, differentiate y1 square plus y1 squared as it is, differentiate bracket. Product. Differentiation of y1 squared. Differentiation of y1 squared is first 2y1 power y1 power minus 1. Then differentiation of y1 is what? 2y1 y2. Differentiation of bracket. Bracket is 1 minus x squared, 1 differentiation 0, x squared differentiation 2x, bracket differentiation minus 2x. In the right side, m squared constant, differentiate y squared. Differentiation of y squared is first power y power minus 1, then further y with respect to x, y1. Here y1 with respect to x, y2. Here y with respect to x, y2. 2y, y1. Dividing by 2y1. This is 1 minus x squared. If you divide by 2y1, y2. Divide by 2y1, it's y1. Divide by 2y1, it is m squared. There. One minus x squared into y2 minus xy1 minus m squared y equal to 0. same type. E to the power of m sin inverse x. Same type. If y equal to e to the power tan inverse x, prove that 1 plus x squared into y2 plus 2x minus 1 into y1 equal to 0. So this given y equal to e to the power of tan inverse x, differentiating with respect to x, y differentiation y1, differentiation of exponential as it is into differentiation of power. First as it is, then differentiate power, differentiation of tan inverse x, 1 by 1 plus x squared. y1 equal to y1 equal to replace e to the power of tan inverse x from 1. This e to the power of tan inverse x is y. On cross multiplying, one plus x squared into y1 equal to y. Differentiating again with respect to x. Bracket first function as it is, differentiate second function. The second function as it is, differentiate bracket. Differentiation of y1, y2. Differentiation of 1 plus x squared is 0 plus 2x, 2x. Y differentiation, y1. One plus x squared into y2 plus 2x y1 minus y1 equal to 0. 1 plus x squared into y2 plus y1 common. If y1 is common, 2x minus 1. Replace all. If y equal to e to the power tan inverse x, prove that one plus x squared whole squared into y2 plus 2x, 1 plus x squared into y1 equal to y. Same. Statements are same, but result is different. Small change. Given y equal to e to the power tan inverse x. Differentiating with respect to x. Y differentiation y1, differentiation of exponential, first as it is, composite, differentiate power. Y1 equal to e to the power tan inverse x by 1 plus x squared. On cross multiplying, one plus x squared into y1 equal to e to the power tan inverse x. 1 plus x squared into y1 equal to e to the power tan inverse x y from 1. Here 1 plus x squared whole squared, therefore square. Squaring both hand sides. Square bracket, square y1, square y. Differentiating again with respect to x. Bracket first function y1 squared, second function. First function as it is, differentiate y1 squared plus second function y1 squared as it is, differentiate bracket. Differentiation of y1 squared 2y1, y1 differentiation y2. Differentiation of 1 plus x squared is 2x. Differentiation of y squared is 2y, y differentiation y1. Differentiating with respect to x. 1 plus x squared whole squared as it is, differentiate y1 squared. y1 squared as it is, differentiate 1 plus x squared whole squared. Differentiation of y1 squared is 2y1, y1 differentiation y2. Now differentiate 1 plus x squared whole squared. If you differentiate power bracket power minus 1 after power differentiate bracket 2x. It is equal to 1 plus x squared equal to the power of 1 into 2x. Right side is y squared. Differentiation of y squared is 2y, y differentiation y. This is a power function. First differentiate per power. Power bracket power minus 1. After power, differentiate 1 plus x squared plus. Dividing throughout by 2y1. This is first term, delete 2y1. This is second term, delete 2y1. Divide by 2y1. If you divide by 2y1, it will be equal. If y equal sin a cos inverse x